Hey, everybody. Welcome to the Audio Programmer Meetup. And I'm Josh, the founder of the Audio Programmer. And here we are. We have this second Tuesday of the month event that we've been doing for over 3 years now. And we always try to do our best to bring people on to the meetup who are both experienced and people who are also getting into the industry. And I'm particularly excited about this meetup because we have two PhD students, one from LA and the other one studying in London. And they're going to be presenting some of their perspectives on some awesome new ways to do things. And so we have Nathan Blair, who is in LA, and Max Graf, who hails from Australia, but is now studying in London. So before we get started, just want to let you know about our audio programmer community. So it's a place where we all get together to talk about building audio software products. And now we have nearly 10,000 members. And if you'd like to join us, it's free. I encourage you to join. There are a lot of people in there that are experienced and some new, quite a few new people as well. So you can join us there at youtube.com/, or actually it's the audioprogrammer.com/community. And with that, we'll go ahead and jump into our first talk from Nathan Blair. So Nathan is a PhD student at University of California in Santa Barbara. He's also been making plugins for about 2 years and also does digital signal processing. And he created this really awesome template for people to get started if you're concerned. So one of the biggest concerns with creating audio plugins is always making sure that you're keeping real-time safe. So meaning that you're safely able to pass parameter values when a user changes a parameter value on the user interface, that is relayed safely back to your audio signal graph. And so the title of his talk is A Template for Real-Time Safe Audio Plugins. And with that, I will hand it over to Nathan. Take it away.
Thanks, Josh. I'm just going to share my screen. Let me know if this works. Can you see the presentation?
Yep, you're all good.
All right. So this is my presentation on the template that I created. This is a template plugin for developers to get started creating audio plugins, and basically it's just the result of what I've been working on for the past couple of years, kind of the direction that my plugins went. Eventually it was useful to start from not a complete blank slate, but to have some guardrails. And so these are the guardrails I put up for myself. That being said, there are plenty of really great template plugins out there. Sudara's JUCE comes to mind, but there's like 10 or 15 of them if you really dig deep online. So I recommend you go out and search for other templates as well. Before exactly introducing the template, I want to go into some of the motivation for it. And so a big thing for me was focusing on real-time safety, which is this concept that you want to, I'll explain it a little more, but basically you want to make sure the plugin is able to run in real time. And learning about real-time safety, I mostly got this information from Timur Jomler, as well as Fabian Offer and Dave Rowland, and a number of other people on YouTube. So I want to shout them out. And I'm going to do my best attempt to go into some of that info too before talking about my particular template. So this is the GitHub repo. It's called the template plugin. Maybe regrettably, I didn't come up with a better name. But if you go to github.com/ncblair/Nathan_template_plugin, you can find that. And this is the agenda for today. Okay. So I just want to start by recognizing that there's a lot that we do as audio programmers. So it's not just that you have to be a good programmer, you also have to be a good music producer. You have to know about user interface design. You have to know about memory management and really low-level programming. And so one of the challenges with developing a template is that you do have to go, or really developing any plugin, is that you have to touch on all these different areas. And I have this little model of how plugins work within a host. So the model that kind of helps me understand what's going on in a plugin is that you have some data that's kind of stored in the center of your model, I guess, and you have two threads interacting with that model. So two processes, a message thread, which mostly handles the user interface and user interaction and outputs the screen pixels, and also an audio thread, which is running at high priority and outputs the sound. And so the goal is always to keep the audio thread running as smoothly as possible, while the user interaction is maybe modifying some of the data that the audio thread is reading. Having that separation, I think, is really important in writing code that doesn't have like crazy bugs. So as much as possible, keeping the message thread and audio thread separated, and just having like a safe data layer is going to be a really big emphasis for my template. And on the right, you're seeing a plugin that I worked on called Carp, and that is just kind of an example of a plugin interface. I'm sure since this is the audio programmer channel, everyone's seen what a plugin looks like. Okay. And then another piece of my philosophy for this plugin template was that as much as possible, I wanted to avoid relying heavily on the JUCE library. I've noticed this is a common pattern for audio programming people that I look up to, and I think it's helpful to be able to reuse code in other situations, and also because the JUCE library has certain portions of the code that not that they're necessarily unreliable, but they're maybe more specific than the documentation lets on, or it's doing some stuff in the background that you don't fully understand. So as much as possible, I wanted to focus writing like custom C++ and even C. Okay. So as we kind of touched on, plugins are these multi-threaded programs. And so you're going to need some thread synchronization. And they're also subject to a real-time constraint, which means that if you don't output audio in time, you're going to get a glitch or a pop or something bad is going to happen. And so this is a little diagram of audio blocks outputting to a speaker. And the emphasis is that there's a certain amount of CPU cycles in each of these to produce each of these audio blocks. And if you don't do your computation within that amount of time, you're going to miss a deadline and you're going to get a like a bad sound. Yeah, so if you heard any of those clicks, that's an example of some bad sounds that you're not going to want to get. And so this is a little calculation for that CPU budget. You have your clock speed of your CPU times the buffer size, which is the number of samples that are being processed at each audio callback, divided by your sampling rate and your number of channels that you're processing. So usually 2 channels, maybe around 44,000 samples per second. And on a really, really crappy machine, that leaves you with not that many CPU instructions. So this is maybe on like an old Raspberry Pi or something. Not something we're targeting necessarily, but even on a more modern machine, you don't have all that many CPU instructions per audio block. So 40,000 seems like a lot, but once you get into quadratic runtime algorithms, you're pretty much out of luck. And memory lookups can take up 100 instructions if you get a bad cache hit. So yeah, definitely not that many instructions per sample at all. You do have to make these programs really efficient. And to put that into more human terms, it's about 6 milliseconds per audio callback. Okay, so because we have this firm real-time constraint and we have to get these audio blocks out really fast, we need to write deterministically fast algorithms. So the emphasis is really on deterministic, because if the runtime varies a lot between audio callbacks, you might get 99% of the time no problems, and then 1% of the time you get an audio click, and that's still going to make your plugin pretty useless. So one thing that we really want to avoid in the audio callback is locking it, which means that it would have to wait for another thread to finish its work. So basically, in most multi-threaded programs in other industries, locks are super useful. Like, it'll prevent our program from crashing, and we'll just be able to lock the one thread, get in, mess with the data, and then finish the thread's job later. But in audio, if the audio thread gets blocked by the main thread, then the main thread is really slow, we're going to have a problem. And not only that, even if the message thread or the main thread is performing a really fast operation, there's a chance that the operating system is going to come in and interrupt the message thread because it's typically running at a lower priority. And that's something called priority inversion. And so what'll happen is the audio thread will be locked out by the message thread, and the CPU will see the message thread running at a low priority and go work on some other task, which is while the audio thread is still waiting. So that's a really bad case. So any lock is not going to be a good idea, pretty much. We also want to watch out for operating system calls. So anytime we're interacting with the thread scheduler, creating processes, and importantly, allocating and freeing memory. It's a big one that plenty of people have talked about before, I'm sure on this channel and definitely on the JUCE channel. But that's a big challenge compared to other disciplines. Is in audio, you have to be really careful about where you allocate memory. And as well as obviously, you don't want to create and open a file on the audio thread, and even printing to the console. So there's a lot of stuff you have to be careful about there. In particular, with allocation and deallocation, you got to really watch out for functions that internally allocate memory. So dynamically sized arrays, and maybe map dictionary type data structures and third-party libraries. So third-party libraries, we don't necessarily know if the code they're writing is real-time safe. Most libraries don't document that, and even the JUCE library and the C++ standard library aren't all that great at documenting whether or not the certain functions are making an operating system call or not. You kind of have to infer that. So that's another reason, as much as possible, I try not to overly rely on the JUCE library, and just try not to overly rely on third-party libraries in general, unless they're very specific about the fact that the code is real-time safe, or if I can read the code and really see for myself. Okay, in particular, I want to talk about these JUCE slider parameter attachments. So this is maybe you've seen this if you've done any audio programming before. It's a really common design pattern in JUCE, and it's kind of in many of their, many of the tutorials online. I'll say these actually work pretty well. I haven't encountered really issues with the JUCE sliders, the slider parameter attachments rather, but they do make this trigger async update call from the audio thread potentially. So it's going to happen when you're automating parameters in certain hosts. You're going to get a trigger async update, and the JUCE documentation says that this posts to the system queue, and it may block the audio thread. So that's generally bad. I haven't necessarily had issues, but because even the JUCE documentation itself says that this is making a system call, I tend to prefer to avoid the JUCE slider parameter attachments if possible. So in my template, I focus on avoiding those and coming up with a different method for synchronizing the user interface with the audio. Okay. Normally I'd ask for questions here, but I'm gonna just go on ahead. Yeah, so okay, we can't use locks. How do we share data in our plugin without locks? So basically the solution is what's called an atomic object. You can use the standard atomic object from C++. And using atomics, you can build more complicated data structures like lock-free queues, real-time safe spin locks, read copy update objects. These are all things that if you look up Timur Domler on YouTube, you'll find some good information about. And basically atomics are these really lightweight data types that you can access safely between threads and that aren't going to stall like a lock or a mutex. And when you want to make make changes to state and access those changes without using the listener callbacks, like we said, the JUCE listener callbacks are sometimes problematic. I prefer to just like pull the information. So that means that I have a timer and I'm just checking the parameter values on that timer, checking the atomic values. And that makes it really easy to write this compartmentalized code. You don't have to worry about functions that when you set a certain piece of data, it triggers another function. In my opinion, it gets confusing when you use callbacks, even though it might be slightly more efficient. It also runs the risk of callbacks getting triggered on the wrong thread and having data races or non-real-time safe code. So as much as possible, I try to implement polling in my plugin template. And I just want to also quickly shout out Perfetto by Sidara Williams. This is a tool that I use to optimize my plugins. It's not really related to my template, but I find it extremely useful for finding those areas in my code where something is going wrong, where there's an operating system call, or where there's like just some really slow memory access that's happening. So I recommend checking that out. It shows like a nice kind of graph of all of your function calls. So super useful. Okay. Now, all that being said, I would like to present my template for JUCE. So basically, the main kind of contribution of this template is a state management class. And this is this like real-time safe API for accessing and saving your state, loading that state from disk, and also creating plugin parameters. I also have these parameter sliders that rely on polling instead of the listener callbacks. And I give an example audio processor class. I also give a CSV file that you can write down parameters in a simpler way, and I'll show this in a second. So instead of having to worry about creating your audio processor value tree state or getting into the weeds with the JUCE audio parameters, you can just edit a CSV file, and I found that extremely time-saving. And I'm also including a build script with CMake. So I do build my template plugin with CMake, not the producer. So in that sense, it might be a little bit more difficult to set up for beginners, but I think it's really worth it because it makes it really easy to run the code on different platforms like Mac OS or Windows, and in my opinion, it's just faster to work without the GUI at the end of the day. Okay, now I think I have to stop sharing for a second and reshare my VS Code. So I'm just gonna quickly show you what some of this code actually looks like. How are we doing on time? It's okay.
You're all good. Plenty of time.
Okay, so this is one of the H files, one of the header files for my JUCE template. It's the state manager class, and I'm just going to walk through this one really quickly so that if you are interested in using this template, you maybe know like some of the places to look when you start using it. And like I said, it's not the most beginner-friendly template, so I think a walkthrough is important. So actually, I'll start in the plugin processor. So this is maybe something you're familiar with if you've done JUCE code before. You'll notice I split the plugin processor and make that a little bigger into a base class and a regular class. The base class is going to have a lot of boilerplate and stuff you generally don't change. And this is all based on the JUCE CMake example template that comes with the JUCE library. But any of the actual processing code or any of the setup code in your plugin is going to go into the plugin processor.cpp. And so in my example, I set up this gain, which is an audio processor class that I wrote, and it's just a pointer to a class with a process call. So it's very simple, but you do any processing in here in the process block. And when you want to access a parameter from your state, you have this state object. It says state, and you get the parameter value from the state using this enum, which is very handy for the parameter. So let's go back to that state so you can see that. There's the parameter value call, which is the main way to pull the parameter values. But if you want to get a little bit more in depth, there's also these functions that you can call from the user interface if you want to set a parameter or reset or randomize the parameter value, or maybe you want to get the text of the parameter because you want to display it on a custom knob or something like that. And I have some functions to manage presets, some functions to manage the value trees that are storing the state of the plugin, and as well as some listener callbacks. Basically, I'm not doing anything in these callbacks besides marking that some change in the state has happened. And that's kind of like a micro optimization so that we're not doing anything unless something has changed. I'll show you the parameter CSV file. So for this example, it's really simple. We have a single parameter called gain. It goes between 0 and 100. And this grain parameter just basically says that any value between 0 and 100 is valid with a 0. But if you had that set to 1, it would only be integers, for example, or set to 2, it would only be even numbers. This exponent value goes into the JUCE normalizable range, and I have that just set to 1, so it's going to be linear scale from 0 to 100, the parameter. And I'm giving a default value of 50. So maybe some people are going to be upset that I didn't use decibels for gain, but this is just percent loudness, so like an amplitude. This little tag here determines if the parameter is automatable. And so I allow you to create these parameters that are not going to be exposed to the host. So if I set this to 0, that parameter would not be exposed to the host. It would not be automatable, but you'd still be able to access it in the same way through the state manager class. And then I give some like convenient text functions basically. So like you can add a suffix or a tooltip, and you could even add what I'm calling a two-string array, which would basically, if you had like a audio parameter that only had a couple options, you could put like, sorry, Copilot's messing me up here. You could put like, this is a bad example for gain, but say you wanted like a filter type. So you could say filter type, and it takes on possibility between 0 and 2 with a grain of 1 and an exponent of 1, default of 0, automatable, sure, filter type, no suffix, that name, and then you could give it like low pass, high pass, and band pass. Okay, so that's what you do with the two-string array. This would just say that the three options are low pass, high pass, and band pass. All that information gets run into a pre-built script and set up in these convenient like C++ objects that you can access in your code. So here's that parameter enum that we saw where I said param gain. I think I'm going to leave that here. You can go through this code. Feel free to message me if you have any questions. Either you can shoot me a message on Twitter if you want. Yeah, I mean, I could keep talking about this for a while, but I think for the sake of the demonstration, that should be good. And if anyone has questions, I'm happy to answer more about that.
Thank you so much, Nathan. That was awesome. Yeah, really well described. And it's really awesome to hear somebody who's relatively new coming into this space, taking inspiration from some of the people that have been talking about this for years, like Fabian Rangiles, Dave Rowland, Timur Dummler. They're legends in our industry, and really cool to see that you've taken that and you've expanded upon their ideas. At the moment, we don't have any questions on the YouTube, but I will give just a few seconds for this to catch up. If you have any questions, please feel free to ask.
Yeah, thank you so much. And I want to just say the Audio Programmer YouTube channel has been a huge inspiration for this as well. So there's been a lot of great content that I've definitely taken inspiration from. And yeah, it's a great community. So thank you so much for having me.
Yeah, no problem. Yeah, it's an honor to have you. Okay, so somebody is typing a question, or at least they're saying they're typing a question. I'll give a moment here for them to. So one question is, did you think about grouping of parameters?
Yeah, so this is something that someone brought up to me like immediately after I released the template. And it would be convenient if instead of a CSV file, this was like a JSON file where like you could say, oh, I want like an LFO type parameter that has a filter cutoff, it has a Q value, and it has a filter type, but I want to make 3 of those, right? So then I could just say like 3 times this object in JSON or something. So yeah, maybe using like something other than CSV will be in the future, and you could have like groups of parameters. I haven't gotten around to it yet because I've been pretty busy this summer. But I think if there's ever a version 2 of the template, it'll definitely come with a way to like kind of group parameters in interesting ways.
Great. Coleman asks, what are some common pitfalls for beginner audio programmers in your opinion?
So like when I started this, I was coming from Python, right? And so like I immediately went to, oh, I want to just use the torch library in C++, but I didn't know any C++. And so like when you're coming from Python, you don't know anything about memory management. Like I had taken a C class in college, but I had been a while. And so I think like the memory management stuff is a really big pitfall, like not allocating memory on the audio thread, not using third-party libraries. Like I'm sure the Torch library in C++ is allocating memory all over the place. And so if you're going to use that library, make sure you're doing it on the main thread and then somehow getting that information over the audio thread. And then sharing data between threads is really quite difficult. Kind of any way you do it, if the data is more than an atomic. So I said you can use this like spin lock object that Timur has written about, but it's not trivial to implement that. I do want to shout out Krill. It's a work in progress library by Timur. I think it stands for like the concurrent real time. I don't remember the library name, but if you just look up GitHub Krill, CRILL, I think you should be able to find it. And that has some good like data structures for doing these real-time safe stuff. But I would say like don't necessarily worry about all this real-time thread communication stuff right off the bat. Just get your hands dirty, start making stuff, start putting stuff out, and you'll run into these issues eventually.
Yeah. Would it be safe to say that JUCE's built-in tools like parameter attachment are great for probably 80% of the situations, and then you're going to have a 20% that it won't work, right? Would you say that that's a fair percentage?
Well, I mean, I think actually like the JUCE parameter attachments, as far as I can tell, any of these like um, trigger async update calls, they're probably not going to block the real-time thread. Like they might block it for like a tenth of a millisecond or something, and your audio callback will just be a little bit slower. So, you know, it's technically not real-time safe. If you want to still use those parameter attachments, I think it'll probably be fine. But it is going to add some uncertainty to whether or not you're able to meet those CPU budget deadlines in time.
Fantastic. There's a question from Oliver who asks, do you need to use CMake to make use of this?
So you could take the code. You could just take bits of the code if you want. But it is set up for CMake. So I'm sure there's a way to port it into like a producer thing. I haven't tried that. I really like, I'm not a fan of using the producer myself, so I've kind of avoided it. But yeah, it is, I think, mostly CMake. But if you want to just take snippets of the code, then feel free.
Great. Yeah, that's great motivation to get into CMake. Got to do it. Yeah, producer is great when you're getting started, but try to get into CMake as soon as possible. It'll open up a lot of things, and actually, I believe, at least from my experience, in the long run, it makes things much, much easier, especially when it comes to third-party libraries. So Andrew asks, how fast is the timer polling for the parameter values?
Yeah, that's a really good question. Let me actually just check what I have it set to. You can, there's like there's a constant value in the plugin editor.h file. I have it set to 60 hertz, which I think is fast enough that it should show up pretty much real time as you're sliding the knobs. But you could change that. You can make it slower if, say, you have a ton of parameters and you don't want to be pumping that engine as often. Or you could even make it faster if you want.
Great. Andrew also asks, have you profiled the performance of using the timer versus using listeners?
You know, when I've ever profiled this, what I realize is that the slow part of my code is somewhere else. So for any real plugin, the like pumping the parameter listeners in like a 60 times per second, pumping like a timer 60 times per second and doing like a couple if statements is not gonna really slow you down. The thing you have to be careful about is that if you have a parameter that when it changes, you're triggering like a big function call, that's going to be something that's slow. And that's the reason that I'm only like updating a parameter if it's changed. So I have some like atomic values that I'm checking that says if a parameter is changed, and then I'm only doing like the like the action that has to happen after that parameter is changed in the main thread if that parameter is changed. Um, so yeah, to answer your question, I'm not 100% sure like the exact performance differences, but I'd say that it's probably not going to be your bottleneck.
Fantastic. And he says, love the work. Thanks for the answers. So there's a question from Hayden who says, your breakdown of audio thread performance was great. I had performance issues accessing stood unordered map recently. Do you know what causes containers like that to be so slow?
Yeah, so when you're dealing with an unordered map, that's actually a non-deterministic runtime algorithm. So that means that like for like hash maps, 99% of the time they're going to be like instant. You can just look up something in a dictionary, but then there's that 1% of the time that you get what's called like a hash miss, or I think that's what it's called. And you might have to like do some linear time operation searching through a bunch of keys, or you it might even be slower than that. Um, so that's something that I try to avoid on the audio thread. I don't think it's usually the thing that's slowing my code down. I have used it on the message thread quite a lot. Um, but yeah, definitely something to watch out for, those like non-deterministic runtime algorithms. And a lot of the C++ standard library is kind of dangerous to use on the audio thread for really deep reasons like that.
Nadaloon asks, what are your thoughts on utilizing the GPU for parallel processing of audio?
Yeah, I think it's a really good idea. So what you have to watch out for is that the GPU is going to be like really non-real time safe in a lot of ways, because you're going to have to like communicate between an entire separate processor and send the audio back to the CPU. So it's probably going to require some like operating system interaction and blah 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 memory movement. Um, so if you do the GPU thing, I'd say probably you're gonna have to break some of these rules first of all. And the other thing is that you want to do it on like a background thread, and then maybe send audio into a queue, and that queue is going to be read to from the audio thread. But yeah, I think there's a lot of interesting applications. Like you could have like 256 parallel filters, and it's like for free because it's on the GPU. But yeah, I'm not exactly sure. Like it definitely doesn't help in every situation. Obviously, with machine learning, we're going to want to do some of those algorithms on the GPU.
Great. I think that's it for questions. Thank you very much, Nathan.
Yeah,
Really
thank you.
fantastic. Yes, and with that, let's go ahead and just segue right into our next talk from Max Graf. So Max Graf is a PhD student at Queen Mary University of London, and he is going to be talking about this really interesting tool that he's been using for creating user interfaces for audio plugins using JUCE and HTML and CSS. So this is a very active space for anybody that's been kind of following along with audio plugin development lately, just thinking of easier ways that we could create richer user interfaces. And this looks very interesting, and I'm very curious to hear more about this. So the title of the talk is called Ultralight-juce, Integrating Lightweight Web Interfaces with JUCE Applications. Over to you, Max.
Hey, thank you for the introduction, Josh. Let me share my screen. Here we go. Yeah, as Josh has said, I'm Max. I'm a third-year PhD at Queen Mary, and I've been working on audio apps for a while now on the side. And I've made a framework for creating graphical user interfaces in JUCE called Ultralight-juce, which is which is what this talk is about. First, a quick overview. I'm going to start with the motivation for this framework and then talk about the idea, so what goes into it. Then go a little bit deeper into the framework itself. Then I'm going to show you 1 or 2 demos and talk about the limitations and outlook for the future, and then finally questions. So first, the motivation. As we all know, JUCE is beyond amazing as a framework for building audio applications and plugins and all of these nice things. But at least personally, I've worked with JUCE for about 5 years now, and I have found that making, so designing, building, and especially iterating on plugins, on user interfaces in JUCE is a great number of things. It is slow. So here on the screenshot, we can see the code for defining a couple of components, I think for Flexbox that is, and then styling them, and all that has to be done in code. It is tedious. Every time you change something in the GUI, you need to reload the entire application or recompile the application, which if you are a person like me and you make loads of changes in your user interface to like try out different things, amounts to a lot of waiting time. It is brutal. You need to read a lot of documentation, which can be a good or a bad thing. I think it's both, but on the right, you can see the screenshot of the list box element in JUCE, which has probably about 30, 40 functions for having a simple like component that renders a couple of pieces of text or whatever. And it's dissatisfying. All of these are subjective, by the way. So here, like after 1 or 2 hours of like the advanced tutorial in JUCE, you get something that looks like this. And it is not particularly pretty, I would say. And last of all, it's great because all of these are very negative. It's obviously like a great library and a great framework for making user interfaces still. You can do pretty much anything. The documentation is amazing, I would say, and a lot of people have made it much easier. For example, I think we all know plugin GUI magic, but the main problem that I've found with it is time. So it takes a lot of time to read through all the documentation and to configure everything, set everything up, make it look nice. And then if you want to change something, basically go through that whole process again. So I've just lost a lot of time on it, and hence the idea of making this whole thing a little bit easier and quicker. So the main idea of the framework is to simplify the process of creating and iterating on GUIs, and using HTML, JavaScript, and CSS for the like GUI definition and interaction, because as we all know, the web design and web development world has gone rapidly and very quickly over the past 20, 30 years with the establishment of the internet, blah, blah, blah. There's loads of GUI frameworks, React, Angular, Svelte, and the nice side effect of all of this is that making GUIs in JavaScript and HTML is now pretty easy, I would say. Obviously, that's not the first framework to do this. There are a couple of others with the idea of using HTML, CSS, and JavaScript for JUCE GUIs. Especially, I've known and used React-JUCE myself, but all of the ones I've tried, and I don't think I've tried all of them, but a couple have had limitations that eventually drove me to make my own, with the requirements that it's lightweight, easy to integrate, and most importantly, not replace the whole JUCE GUI ecosystem, but rather just extend it. So the framework, so the Ultralight-juce framework is built on the Ultralight framework, hence the name. And Ultralight is a high-performance HTML renderer supporting JavaScript and CSS and HTML. It's written in C++, so it integrates nicely with JUCE and CMake. And it's based on the WebKit browser engine, so like that's the same one that Safari and the iOS browsers use, which means it virtually supports virtually all browser or web development and web design features out of the box, which is very nice. So now a little bit more about the features of the Ultralight-juce framework. It's like JUCE and Ultralight cross-platform, so it runs on Windows, macOS, and Linux. It supports side-by-side rendering, so you can either do your whole GUI in HTML and JavaScript, or you can do everything in JUCE and just have a little tiny component that you just couldn't get quite right in JUCE with HTML and JavaScript, or you can literally like render them side-by-side, component for component. What I usually do is do some of the base stuff in JUCE and then overlay an HTML layer on top of that with a transparent background, and you have a beautiful user interface pretty quickly. The framework supports C++ and JavaScript interoperation to a degree. I'll get into that later. So for passing data between C++ and JavaScript, it is. It has a pretty rudimentary, I would say, state management system by now. It has hot reloading, which is one of the things I made it for. So you can have your plugin running, like we saw in a couple of other examples as well. I think C Major has it, where you can like change some bits and automatically it reloads. It's the same thing here. So all the JavaScript, CSS, and HTML, you make a change, it automatically reloads. You don't have to restart your plugin. You don't have to recompile. It's just very quick and very easy. And something that I use quite a lot is it supports JavaScript libraries, which is super nice. So if there's like a fancy knob or a fancy slider or a fancy progress bar, which has like 50 lines or 500 lines of JavaScript, and you don't want to write your own, you can just like drop the library like in any other website or web application, and you have it in your JUCE plugin. So let's go a little bit deeper into the tech of the whole thing. So to integrate it, there's a couple of steps. First, you just need to configure Ultralight, which is like described extensively in their docs. We set up the file system, we set up the font loaders, we decide whether we want to render on the CPU or GPU from Ultralight. So that's all about the Ultralight rendering. We define an Ultralight view, which is approximately what a JUCE component is. So this Ultralight view takes an HTML file and renders it. It takes some JavaScript and CSS and handles it. And then it renders it, which I will talk a little bit more on the next slide. And then we have an image and we do something with it. And then optionally, if we want to make it interactive, we can pass mouse and keyboard events like standard JUCE stuff. And yeah, if desired, probably desired, continuously update it, for example, with a timer, and you have an interactive user interface in HTML. A little bit more about the rendering. So for the rendering, we define the layout and the interactions in HTML, JS, and CSS. And then Ultralight internally renders an image from that, however many times per second you want, so that you can run it at 1 FPS, you can run it at 60 FPS, but you can also run it at 300 FPS if that's something you want. Ultralight is super fast and that works really well. And then you have an image. And either you can render the whole image, overlay the whole image, or what I'm using a lot, which is super nice, you can selectively update parts of the image based on data you get from Ultralight. So say you have a whole website with 200 interface elements, and then you click a button, and that button click is animated, so the button turns green or red or whatever. And then your whole window says 1024 by 768 pixels, but the button is only 50 by 50. So if you click the button and it updates and it animates and it does stuff, Ultralight will be like, hey, your image is updating, but only in this little rectangle here. So you can just take the new data from the rectangle, update that, and that makes the whole thing very, very fast. And then finally, you take this image and do something with it. So either you display it with JUCE's image class, which I've done in the demo project with GitHub, or you can render it into a texture and display it with OpenGL, which I will also show you later. And then we have something like this. This is the basic setup that you get from on the GitHub project for Ultralight-juce. So that's what it's the quintessential knob window with a couple of things, but with all of the things that I've talked about now, it's not interactive. So none of this will do anything. And to make it interactive, we need interaction. So I've dubbed the philosophy of this framework unopinionated, which is basically just saying very, very small batteries included. There are templated methods for handling C++ to JavaScript and vice versa data transfer. and it supports primitive data types and strings and lists thereof in any combination, but nothing more fancy. I will talk about that later a little bit more. To sync audio parameters, the audio processor value tree state APVTS is synced bidirectionally, following a basic like model view component controller pattern. So in HTML, we have a little knob, and we drag our little knob, it changes, it sends a change value from JavaScript to C++ through a custom function, which is like standardized, that updates the APVTS. So the model is updated, the changes propagated back from C++ to JavaScript, and finally the HTML layer is updated in the form of the knob is twisting. Here's an example of how this could work. That's not for the knob, but for a button now. So this is HTML. We have a little button, and it has a little function called onMyButtonClick, taking 3 arguments, an integer, a string, and an array of integers. And if we click that button, we can register the callback like so in C++. We can define a lambda function, essentially saying we take an integer, a string, and a vector of integers, like we see here. And then when we click the button and register the callback with our second standardized function, so we just say onMyButtonClick, do button click callback. onMyButtonClick is the same method name as here in JavaScript. And now if we click the button in HTML, we will get the data in here. And vice versa. Very similarly, in C++, we have a standardized method called invoke method, which is templated. You can pass any of these data types that are described, and it will invoke the method called whatever you pass it in JavaScript with whatever arguments you give it. And in JavaScript, you have your method called myJS function, and then you can do whatever you want with the arguments, and suddenly you have interaction. A little side note I have here, because we're dealing with HTML, JavaScript, and CSS, one common thing to like go into these in web development, is to use an inspector that is also supported by the framework. So you can use the same inspector as Safari gives you, which is the same as Chrome uses, and so on and so forth, allowing you to inspect your elements and do all the nice things you can do with an inspector, except one thing, which is crucial, which I will talk about later. And with all that said and done, I will show you a quick demo of what it looks like. So let me open up my Ableton. I have a track loaded, and I have my plugin here. And that's the same one we saw before. And if I play that now, you should hear the audio through Zoom. I can take the knob, I can change the gain, I can silence it, I can bring it back up. Very, very basic, normal stuff. I can automate it, I can change it to modality. Pretty straightforward. But now I want to show you some more fun stuff. Where is it? So this is a separate app that I've been developing, which I've kind of developed the whole framework for, because I got so angry changing things. So in this app, we can see what I described before. We have a background layer. So what you see, the little colorful dots, those are all rendered in OpenGL. But then the whole overlay, everything else you can see, all of the buttons, the bar up top, all of that is HTML, JavaScript, which makes it very easy to have like nice transitions and animate everything and lay out everything pretty quickly. And like I had the exact same plugin layout in JUCE before, which took me probably 2 weeks to make. But then I could just make it in 2 days in JavaScript. And the lovely thing about it is, so I have this little button here, which just like resets the view, right? And then say I want to make this button a little bit bigger. I just go here, I say 128 instead, and 128 instead. I save this, it reloads. I have a big button, and say I want to make it green. When I hover my mouse over it, I change this, it is gone. It turns green when I put my mouse over it. And all of these things basically make it very quick to play around with your UI changes. And yeah, saved me personally a lot of headaches over the past few weeks. Cool. So a little bit about the limitations of this. It's very young, so there are a lot of things to address still. Complex data types for C++ and JavaScript are not supported because I believe, at least, I may be wrong, but I believe that there are so many use cases and so many people would want so many different things that like implementing 7 of them but not the other 14 might actually be not the best idea, because then everybody might just end up unhappy. So I've so far left that out, but I guess it might be something useful in the future. The second thing is the Ultralight, so the HTML renderer has a tier system similar to JUCE. So with that one, projects under 100,000K per project per year are free. But if you make more with a project per year, you need to pay for a license. And some of the Ultralight modules and the modules it uses fall under the LGPL3 license, which means you essentially need to provide a link to the source code for those files when you distribute your audio app or plugin, for example, on a website. And then something which a lot of plugin people won't like is that static linking to Ultralight is not possible. Oh yeah, no static linking possible on the free tier. However, I've kind of worked around that issue because I faced it myself. So like the framework comes with some mechanisms for shipping plugins and apps with the free Ultralight tier. So that's included both for Windows and Mac OS. You need to look into Linux as well, I guess. And then the last two, yeah, it doesn't support ARM right now, so you can't build your JUCE apps for Android phones at the moment, but that's coming soon. And the last thing I mentioned before, the inspector usually is used for one thing and one thing only, which is to debug your JavaScript code, which is currently unsupported, but it's also coming very soon, which then means you can debug the C++ side of things in your CLion or Visual Studio Code or VS Code or Visual Studio, and the JavaScript code in the inspector, which will make things a little bit easier and save you many console logs. Yeah, and then finally the outlook. So my plan for this is to bring it to like a stable and pretty state, so like the version 1.0, so to speak. Add some documentation, add tests, and definitely add more examples and demos, because I think those are the quickest way, as always, to get into these things. If you're in any way interested, please get in touch. I'm looking for people to make some cool demos with that. So yeah, and that's it. Try it. Here's the GitHub link if you find it interesting, and yeah, please reach out if you want to contribute. Like, I'm happy to take GitHub issues, pull requests, all of that. Here's my Twitter, there's my email. That's it. Thank you.
Thank you very much, Max. That was really awesome. A lot of people are just blown away and really astounded by this. Even though some people are feeling some pain because it's not supported on ARM. So there are a couple questions, and we'll give a couple minutes for other people to ask questions as well. So one of the questions is there SVG support, and do the image effects like drop shadow, inner shadows, etc. come across?
Yes, so the little button that I changed is an SVG. So there is SVG support. The only filter, okay, actually I'm saying wrong things here, because when I made it, the Ultralight library hadn't been updated for quite some time, and they didn't support, I think, the blur shadow and the box shadow and the drop shadow in CSS, but they've literally pushed a new release like a week or two ago, which means those are now supported. So I think the answer is just yes.
Great.
Once I put it in the GitHub.
Jonathan asks, am I right in thinking that I could use Tailwind CSS or 3.js with this?
As long as you can include it in a like HTML way. So as long as you're not dependent on Node.js, which as far as I know, you are probably not with those libraries, then yes. So like, I've not been too deep into the JavaScript world in the past few years, but as far as I know, most of these libraries offer some sort of like including the script in a minified version kind of way of integrating them. But I know that some like depend on Node.js, and with those you might run into some deeper issues, I would say.
So Colin asks if you can elaborate a little bit more on the static linking issue. So some people aren't quite schooled up on the difference between static versus dynamic linking. Can you just give them a basic rundown?
Yeah. So with static linking, the idea is that you link external libraries on Windows. I don't even know what they're called on Windows. Like you basically link the external library directly into your executable. So if you have like an exe or like a .app on macOS Windows or a .vst3, .vst audio plugin, you will essentially link the library code. So both the symbols, the objects, and everything else you need to run it into your binary. Some people, I mean, there's reasons for and against static linking in a lot of use cases, especially for audio plugins or audio apps. I think it makes a lot of sense. But the alternative is dynamic linking, where you basically have a library or one version of a library at some point in your operating system, and then many apps can link to it dynamically, either at runtime or through some other mechanism. So the reason you can't link statically with this framework is because Ultralight under the hood uses some libraries which are basically not licensed, not made to be statically linked. So you can physically not link them statically. If you try to link them statically, you will run into an error and it just won't build. But again, so I've run through the whole process of test shipping this app I just showed you once, and I've ran into no issues at all. So like there are ways around it. It's just a little bit more annoying.
Great. I think that's it for questions. Thank you very much, Max.
Do you mind if I ask a question?
Of course.
Can you, so I know you said custom data types aren't supported. So like one situation that I run into sometimes is wanting to send like a oscilloscope to the user interface, or display an oscilloscope on the user interface. So basically just sending like a bunch of audio samples.
Mm-hmm.
And so you like need a lot of data. And so even if that's like not supported, one, is there a way to get to that right now if you're going to implement some custom code? And would it be prohibitively expensive, like on the JavaScript engine, to be displaying so many numbers so fast?
I mean, if the oscilloscope is literally just like a set of sample data, then you can just like pass the array. If it's like an oscilloscope of, I don't know, 500 or 5,000 even, you will be able to pass them. Like the throughput is still relatively low, right? If you have a not insanely large number of integers or floats or whatever, and you package them up and you pass them over to JavaScript 60 times per second, it's still a very, very low throughput for the CPU, right? And as long as, like you said, don't do it on the audio thread, it's fine. So like, and like extending it is definitely possible, yeah. Like the framework is written, split up in two ways basically for the interop, and extending the basic interop class is very simple. And then you can write your own JSON object parser, for example, if you want to pass specific objects of specific types in between the two. But yeah, for all my needs so far, I've been happy with the interop functions I have.
Cool, thank you.
Great.
Sounds really cool.
What's that? Great. So yeah, it looks like we're done with questions as well. Thank you very much, Nathan and Max, for these awesome presentations. Really awesome and really forward thinking. really appreciate having you on.
Thank you.
Great.
Thank you.
So with that, we're going to go ahead and wrap up. So we have a couple announcements. So next Tuesday, we're actually going to be doing a on the spot audio programmer meetup, special audio programmer meetup with Hong Chan Choi from Google. He's going to be talking about improvements to the web audio API. It's a really exciting talk, and we're very proud to have Hong Chan with us. And that will be happening next Tuesday at 6:30 p.m. UK. That would be 1:30 p.m. EST, and I will be putting out an opportunity for people to be asking questions about the web audio API. In the meantime, also just wanted to let you know about our next meetup that's happening, which will be on the 12th of September. So we do this every second Tuesday of the month, and we hope that you can join us. Really awesome meetup, really awesome subjects. Really glad to have both of you here. And with that, I will sign off now. And like I said, if you want to keep in touch with us in the meantime, be sure to join our community on Discord. So that's theaudioprogrammer.com/community. We also have a jobs board as well for anybody that's looking for audio programming opportunities. That's on theaudioprogrammer.com/jobs. And that's it. So thank you very much, Max and Nathan. And with that, we will sign off. See you next time.